So continuing with the drag detector series, today we're going to do draggable drawers. And I'm going to use these drawers right here, but you can use a part instead that you can connect the drawer to. So you could just have a part. I'm going to copy this size right here. Same with the position. You can just have a part that you're gonna be able to drag like this instead of the drawer, and then you can attach the drawer to the part. And I'm going to show two ways of doing it. One is gonna be the physical drag style, and the other one is going to be the geometrical one. The geometrical one happens whenever the object is anchored. And physical means that it's gonna be affected by physics, so you will have to connect everything with welds to the part that you are going to drag later. But let's begin. So the first thing we need are the axes. In my case, the drawer is going to be opening on the z-axis right here, because I don't have any pivot offsets, so it's going to be the same as the world position. In like this cube right here that you can see, this is gonna be the z from there. So we need to add an attachment. I'm going to do the physical one first, so this drawer will need a slider attachment. And we can also either add another part, or just add different attachments into the desk. If you saw my previous tutorials, you know already that there are gonna be two attachments right here that we used in the hinge parts previously. So one is going to be the constraint attachment, and another one is going to be the dragger reference attachment. And both of them need to be positioned at the same place as the slider attachment is positioned at. So we scroll down in the slider attachment, we copy the word C-frame position. Make sure you don't copy the C-frame from transform, but from the delivered word data. And we just paste it into the attachments right here. And also I need to make sure that this drawer is going to be unanchored and also set to can't collide. Make sure this is disabled because it's gonna be clipping into the desk otherwise. Now I need to add a cylindrical constraint. Oh, and also, if you can see the attachments or the constraints, you can go into the model and press on constraint details. But now we need to select the cylindrical constraint, go down and set attachment 0 to be the slider attachment, and attachment 1 to be the constraint attachment. And now we're going to see this connection between these two objects. But now in the constraint, in the actuator type, we want to select limits enabled, and now we're gonna see this line right here, and then change this upper limit to be, let's say, 2. And in the cylinder, we also want to enable angular limits, just so it doesn't spin because we don't need it to spin. We set them to 0 and 0. Now with the slider and constraint attachments, we want to rotate them so they are pointing on the right axis. In our case, it's going to be Z. And we also changed the actuator type to be motor, so now we'll see an arrow right here. This is for the physics rendering, but that's it for the cylindrical constraint. Now we need to go into the drawer and add a drag detector. We set the reference instance to be the reference attachment. We can change the activation distance to be like 10, and in the drag style, instead of translate plane, we want to do translate line. And leave the response style to be physical. And now on the axis go by X, Y, and Z. And since we want to open the drawer on the Z axis, we need to do 0 by 0 by 1. So it has 1 on the Z value. Then in here we don't want to add any limits, because we already have limits from the cylindrical constraint. And then we can change the max force to be like 600, max torque to be like 600 also, and responsiveness to be like 80, let's say. And now we can test it out. So if I try to drag it, oh, it's going to drag in the wrong direction. So the thing we need to do now is go to the constraint attachment and slider attachment and just rotate them backwards like this. So you will see the blue line going in this direction instead. And now we can just drag it open, and if I try to pull it, you can see that it's not getting pulled any further because of the limits, and I can also just close it back in. And just to show you that it's moved by physics, I can do this. You can see when I'm letting go and it still keeps moving on the constraint line. But by the way guys, do you know that I have channel memberships now? Where you get all of these amazing perks on the channel and also my Discord server. So if you want to support me, you can go check them out. But going back, overall people mostly struggle with the axis of these attachments. So if I rotate this reference attachment, for example, you can see that this is the x-axis of the attachment. So its z-axis is like this because it's set to the word's position. If this is y and this is x, this is the z. If I were to rotate it like this, now this would be the X and Z would be right here, and I wouldn't be able to pull the drawer because of the axis mismatching. So just as a tip, make sure that everything is operating on the word axis and nothing has any pivot orientation, offsets or anything. And it's quite different with the constraint axis, because for the constraint we need to set it so it only moves on the axis that we want it to move. And yeah, that's basically it. So now going to the geometrical response style, the only thing we need is a drag detector and a reference attachment, which we already have right here. So we just have the drag detector. So we set the reference instance to be this attachment, lower the activation distance, and again change the drag style to translate lane. And this drawer is anchored, so it will automatically change the response style to be geometrical one, or geometric. But we can just change it ourselves too. Again, change the axis to 0 by 0 by 1. And now we want to scroll down to the limits, the drag limits, and we just want to change the max drag translation on the z-axis. This is where we give it the limit to, let's say, 2. And we don't need to do anything with the angle, and we don't have the force settings because it's a geometric drag style. And that's all for this drag detector, so you can do play. And we should be able to just open the second drawer like this. And this lower one, I won't be able to move like the top one, since this one is affected by physics, and this one is not. So just for comparison, I'm just going to open and close them for a little bit. And now, because a lot of people are concerned about this not working on different platforms, first off I'm going to do a test device. Since this is registering the touch input, you can see that I am able to just open and close this, as if I were on a touch screen. They're just a little bit harder to click. So that's how it works on mobile, but I'm also going to plug a pad that I had somewhere laying around. Okay, it should be connected, yep. Why do I have two of them? Oh, now. So wait, which button was it? This one. But yeah, you can see that I am able to just drag them two from a controller. So don't worry, the drag detectors work on every platform. Same with the first person. So that's basically how you make draggable drawers, and it's very similar to the sliding door I did previously. This uses the same constraint and the same method, but on a different model with a little bit of different settings. So yeah, if you want to see anything else from the drag detectors, you can let me know. But that's going to be everything for today, and hope you had a nice day, and see ya guys!